All right, so let's go through and let's kind of talk about a couple of things. So here's our home screen. I'm just going to jump into student view real quick just so you can kind of see what we're going to be looking at today. So I do want to use some of the doodle notes. I have this on PowerPoint too, and that's what I'm going to go over with you today. But there's an activity on there that I feel is worthwhile. So let me just pull up the assignment for today so that you can kind of see what it looks like. So astronomy notes, size of space. I'm going to go ahead and click in there and then just on the title so that you can kind of see it. So these are the notes that we're going to go through today. I did go ahead and make a YouTube video of it, so you can click there in case if anything happens. These are the doodle notes that if you want to pull up and print out, awesome. If not, we're just going to take notes that way. These are here just to help you if you like them that way. I've gotten some positive feedback for them, so that's there. What we're going to work on today is down here, and I'll explain this extra credit here kind of at the end, and then I made one yesterday, me and my daughter did, of the universe on our little side street that runs right next to my house there, so I'll explain that in a minute. But hopefully you should be able to see this button down here. It's kind of gray where it says load astronomy notes, size of space in a new window. So I would like when you get to the assignment to click on that, and I might have to load that into a new screen. Just give me a second. Perfect. So you should be able to see some of the doodle notes. This is actually not the whole portion of it, but this is the activity that I'm going to have you work on today. So what this is, and this is teacher version, so it looks a little bit different. So when you get in here, this is a PDF, and the really great thing about this program called Kami is that we can type right into our scale here or our text here and kind of figure out some information. So this is what you're going to be, this is your assignment for the day. So you're going to be filling this in, and I'll explain how to do that here in a minute. And I've given you some examples. And I'm in teacher view, but there should be some view up here that will say submit, or here it submit or turn in. And as soon as you click that button, it's going to go right back into Canvas for me to be able to see that you've completed it. There is also an option if you wanted to download it and save it to your Google Drive. You should be able to do that. But let me just kind of give you some examples, and I think some other teachers have been using this, so maybe some of you are kind of familiar with it. So let's say you have the option to pick any of these different tools, and so let's say that I wanted to find the scale model of Venus, and that's what we're going to talk about today. Here's my scale value, is that I can click right in here and make the box to whatever size. Well, maybe 24 is too big. Go away. Maybe that will work. And then I can type in that, and this is, I'm making this up, I don't remember exactly. Oops. There we go. So you can rearrange the box to whatever you need it to be. So you can type in your answer right here. That's not 36 AU, but you get the idea. So then you can go down here and do the next one, and so forth, so forth, so forth. So that's where this is going to be nice and handy for you guys to be able to use today. So this is actually your assignment portion, is to go in here, and we're going to talk about how to do this. You're going to fill in and show me how to find the astronomical scale distance of each one of them. So we're going to be using this line down here, which is 21.7 centimeters. I'm going to give that to you. And we're going to figure out what is the astronomical unit in centimeters for each one of the different planets. And so you're going to show me your work in here by typing in stuff. And then you're going to come down here, and this is the only hard part, I'm not really sure how to get around it by any means, is You can get out a ruler or get out a sheet of paper and draw this line out and then just plot in Mercury through Neptune. I'll tell you right now, Mercury is extremely close. As you can see, I got the answer there. It's at 0.28 centimeters. So it's like really tiny. And then Neptune's out here. And you can do that by either just creating a dot if you wanted. However you kind of want to do it and label it. So use this time to kind of work around this. So you'll be doing that today, and then also we're going to scale down the size of the planets to make them something more manageable, meaning that we're going to look at taking a scale factor. We know that Jupiter is our biggest planet in our solar system. So when we do scale models, we're going to be looking at the large size of it. So this is the actual assignment for the day. Let me go through the notes, and I think that will help you a little bit with understanding what the heck this all means, hopefully. So we kind of went over it just a little yesterday, but let me stop sharing here real quick. Let me answer a couple of questions here that I see that are coming. Do spiders have 8 legs? Yes. If we did it on paper, how do you want? I'd like for you to go back and use Kami, Aiden. I want you to get used to this program. It's something that it's the only way that I have it able to be submitted today. So just go back. If you've already done it on paper, great. Just use those answers and type them into Kami, and then just make sure you submit it via that way. Are we doing all 5 pages? Kylie, we are not well, the notes are over all 5 pages, but what is in Kami, what I just showed you, those 3 pages, that's your assignment for the day. And then, yeah, Kylie, if you want to print it out, you can totally print it out, but once again, just make sure that you are submitting the Kami document via Kami. So I'm just trying this out. I know it's a little bit different, but I think that this might help with some of us that don't have printers at home. But clearly, obviously, anytime I have the doodle notes, feel free to print them out all the way. But for some of the assignments, I will say this is a Kami assignment, and I'd like for you to type in the text and then hit submit. So you guys are my guinea pigs with this. So hopefully it works well. I know some of the other teachers have used it as well. I know Miss Bell is the one that showed me how to use this. So I know some of you are in her forensics class. So hopefully that helps just a little bit. Let me go ahead so you can see my face today. I didn't even pull that up. Sorry, I was so bogged down about not having this working, and I was worried you guys are all going to be sitting there. So, okay. Let's take just a few minutes, though, and go over some of the notes just so that you have that there for yourself. So I'm just going to, let me share the home page again. I'm going to leave back here. My house is very noisy today. All right, so back to this page, and we are going to space, and space is bigger and getting bigger all the time. So let's just go through this here. I'm just going to leave it in this format. So a couple of different things. So as you can see, I've got snips of the doodle notes. So if you want to fill it in that way, that's fine. Or if you just want to write this on a sheet of paper, that is fine as well. But some of these measurements are going to become really important as we move through the next couple of days. So just kind of make sure that you have them jotted down somewhere in your notes so that you feel comfortable with it. So the first thing that I want to kind of go over is just the idea of we talked a little bit about dimensional analysis. So I'm going to introduce some scale factors to us today that are going to be helpful with our measurements as we move through the next, like I said, next couple of days. Today and tomorrow, we're mostly going to talk about distances between different planets and the sun and different planets. And then we'll move into talking about the distance and radius of different planets, and then get into even talking about how far is the sun from the next closest star, Betelgeuse, or how far is the Milky Way galaxy closest to its nearest neighbor galaxy, Andromeda. So these numbers sometimes are going to get really big. So this dimensional analysis will help us again. So the first one is just one that we're pretty familiar with. The size of objects like stars and planets are measured in kilometers. And this is measurements that we've already done before. We hopefully can remember that 1,000 meters equals 1 kilometer. And so when we're looking at things in our solar system, especially in just the size of each one of the different planets, we're still going to be working with our metric system. We don't want to measure the planets in meters. That would be crazy big numbers. So we will be using kilometers to kind of help us get through that. Our next measurement brings us into one of our new terms, which is astronomical units. And what this is that it's the distance within our solar system that we measure in astronomical units. And that's what you're going to get hopefully comfortable with today on that activity that I just showed you, is that 1 astronomical unit is just based off of our understanding of, we talked a little bit about this yesterday with everything being relative and what we've decided as measurement factors. So 1 astronomical unit is the distance from the sun to the earth, which is 149,600,000 kilometers. So a pretty far distance. So instead of writing this number out every time, scientists and especially astronomers have decided just to use 1 astronomical unit. So 1 astronomical unit equals 149,600,000 kilometers. And so that is going to be the measurement of things within our solar system. So the sun to Jupiter, Jupiter to Mercury, yada yada to yada yada. And we'll even talk a little bit about things outside of our solar system that are still kind of out there orbiting. So traditionally our solar system, you probably think of it looks like this with our 8. You might still include Pluto out there. He's hanging out there this way. And then even beyond that is the Kuiper belt and the Oort belt, which also have smaller planet-like structures in there as well. Actually, next week we'll talk about it. Is there a planet 9? Scientists are starting to think that there are probably bigger objects that are out there that we just don't have the means to see because their orbital pattern is so long. So for medium though, 1 astronomical unit equals 149 million. So once we move outside of our solar system, we move into our next unit of measure, which is a light year. And so a light year is kind of having to do back with our electromagnetic spectrum. This is our visible light that is traveling to us here on Earth, I should say, from other different planets. So it's the distance between stars and our galaxies are measured in light years. So, and this is normally where I would draw a picture. So this is our Milky Way galaxy here. And our solar system is on one of these wispy arms. It's actually called the Orion arm, which is right out in, I'm just picking one, but it's out here. So like our solar system is here. So we have a great view out into space. And then we have a great view into the Milky Way galaxy. So there are some times that you might see those pictures where they're like, this is the center of our Milky Way galaxy. And that is true because we have a good bird's eye view right into it. So the sun is clearly not the only star in the Milky Way galaxy. There are hundreds of billions of other stars that are out there. And scientists now have even been able to figure out that some of those stars have planets orbiting them as well. So that's our next one. So the distance light year travels in 1 year and it goes pretty fast. So 1 light year equals 9.461, that should say times 10 to the 12th kilometers. So imagine 12 more zeros behind there. Or we could also look at it as 1 light year equals 63,241 astronomical units. So that's a lot. The next closest star is very, very far away from us. I do want you to, if you get a chance tonight, go outside and take a look at the sky. Let me pull it up. I want to make sure I tell you correctly. I noticed it last night. There is a planet that is extremely visible. It should be one of the first ones that pops up as soon as it starts to get dark outside.